At this stage, you should have drawn down this results table onto the bottom of page 90. So you also should have watched the video, and from the video you would have seen the mass of the empty evaporating basin was 30.0 grams. The basin plus the hydrated compound was 31.5 grams, and then the basin plus the anhydrous compound at the end was 30.8 grams. Make sure you have this written down on page 90 before you go any further. At the top of page 91 then, you're asked a couple of questions which help with the calculation for the degree of hydration. You're first of all asked what caused the mass to decrease as the hydrated compound was heated, and hopefully you noticed in the video that it was the water of crystallization being lost by evaporation as the anhydrous compound is formed. You're then asked this question that I've got written here: calculate the mass of water lost. And all you're going to do to calculate the mass of water lost is you're going to take this value here, the evaporating basin plus the hydrated compound, and you're going to take away the value below that, the evaporating basin and the anhydrous compound. So your calculation is going to be 31.5 minus 30.8 equals. And if you do that calculation, you will see that it equals 0.7 grams. So that's really important to know. The two things you need to know for the next calculation is you need to know the mass of the anhydrous compound. So that's the compound with no water in it. And you need to know the mass of water lost. So to find then the mass of the anhydrous compound, as I write this down, so mass of anhydrous compound is going to be then the mass of the crucible plus the anhydrous compound, take away the mass of the crucible. So if we then do that, we can do that from our notes here. We can go the mass of the crucible plus the anhydrous compound, so that was 30.8. Take away your empty evaporating basin, or the crucible, is 30.0. So you find your mass of your anhydrous compound there is 0.8. So those are the two values that we need to go any further. Now on page 91 then, you're asked to calculate the degree of hydration. And this is the wee bit that I want to talk you through. You should have been able to do the other things from your knowledge already, but this is where we put the ideas from empirical formula to something else. So the two compounds we're dealing with here is what's in the hydrated salt. So in the hydrated salt, you have iron 2 sulfate, it was described as. So that just means iron has a valency of 2. Sulfate, we already know, has a valency of 2. So when we swap and drop them, we get FeSO4. Now, looking then at your other compound then is water, and it then is, you should just know, as H2O. Okay? Now, the next step then is just to follow what the table says here. So we're going to write down the mass of each element, or in this case, the mass of each compound. So the mass of iron sulfate we've worked out before to be 0.8. So we're going to write in here 0.8 grams. Then your mass of water, you've also worked that out at the top of the page to be 0.7 grams. Your next step then is to work out the number of moles. Remember, to work out moles, it's the mass divided by the relative atomic mass, or the relative formula mass for a compound. So if you take the mass numbers of iron and sulfur and then 4 oxygens, you should get that to be 152. So your calculation here for the first bit is 0.8 divided by 152. And what that will actually get you is a bit of a random number, and it doesn't work out very nicely at the end. So normally when we work with moles, remember, we always do moles to 3 significant figures. But this one here we're going to do to 1 significant figure. So that will work out to be 0.005. Okay? Look at water then. Again, it's going to be mass divided by relative formula mass. So that is 0.7 divided by 18. And this time we're going to go one significant figure as well, and that's going to be 0.04. Looking at the next line then, we've got to divide both numbers by the smallest number, and the smallest number here is 0.005. So if we do that, 0.005 divided by 0.005, you will get 1. And on the right hand side, 0.04 divided by 0.005 will get you 8. So look at your ratio. We've got to do our whole number ratio, remember? And the ratio here is 1 to 8. So we've got 1 iron sulfate to every 8 waters. So your degree of hydration here is going to be 8 because you've got 8 waters. So degree of hydration is just the number of waters you have to every 1 of your anhydrous salt. So degree of hydration is 8. The empirical formula then is FeSO4 dot 8H2O. Remember, the dot's very important. It tells you that this is trapped within the structure. It's not a covalent bond, but it's stuck in there, it's bonded in there. And then the MR of the hydrated compound is just your mass numbers added together. So you've got that 152 from the iron sulfate plus then 8 waters. So you're going 152 plus 8 18s, and that will get you 296. And I'm just going to write it to the side because that's a very small space for me. Okay, so that's your working out to work out the degree of hydration. You follow that process every time, and that will then help you on page 92. Okay.